Welcome back, Calculus. This is our last kind of formal objective of Unit 5, and we're just going to continue on with U substitution, but this time we're going to apply them to definite integrals, so values with an A and a B. I've got the checklist on the screen. I still recommend a couple highlighters if you're finding that still valuable for the U substitution part. So I will first pause on the screen. You know what to do from here. I want to do just like a little bit of background with definite integrals. First pause on your screen, go ahead and copy the two definite integrals I have on this screen. Alright, so the first one, I've got the integral from 1 to e of 1 over x dx. Now, both of these limits of integration, in other words, your a and your b value, are both x values. How do I know? Because everything is x's there, okay? So I make sure, what I would like for you to do is add an x equals to both the lower limit and the upper limit of integration there, and then let's go ahead and find this definite integral, which means we antiderive and evaluate, right? So antiderivative of of 1 over x is ln of the absolute value of x. I want to evaluate this at x equals e and 1. So this is ln of e minus ln of 1, which is 1 minus 0, which is 1, okay? Similarly, what do you think a and b are for the next one? Are those x values or u values? Those are u values this time because everything is in terms of u, right? So we have to assume that a and b are both u values in this case. So would you put a u equals for both top and bottom there? And again, I would antiderive and evaluate, but I'm going to get the exact same thing, right? I'm going to get ln of e minus ln of 1, which we said was 1 minus 0, which will be 1, okay? So I just want you to be very mindful of your limits of integration here as we start to get x's and u's kind of tangled up. You need to keep in mind that if your, whatever your differential is there, that is the same letter that your limits of integration are here, and we cannot mix the two, okay? So if I'm in terms of x, I need to make sure a and b are both x values. If I'm in terms of u, I need to make sure a and b are both u values, okay? All right, so let's try some. First pause on your screen, go ahead and copy example 1, and then we'll do it together. All right, so notice that I have an inside function, right? I've got this 4 minus x squared, it's inside a square root. Is that function linear? It is not, so I can't do like an anti-chain rule in my head. So I'm going to try a u substitution here, all right? So let's let u be that inside function of 4 minus x squared. And then du, if I take the derivative, is going to be negative 2x. Bring the dx over, and oh, that's good news for us, right? Because that appears right here, okay? So this part we've done before. The only new part is your limits of integration, your a and your b. So right now, the 0 and this 2, are they x values or u values? They are x values. Look at your differential here, where everything's in x's, right? So what I want you to do is put x equals 0 and x equals 2 as a reminder to ourselves, okay? All right, the thing is, we're going to get ready to rewrite this integral in terms of what letter? In terms of u, okay? So I can't have that x equals 0 and that x equals 2. I need them to be u values. Well, not a big deal. Look, I've got a relation, or I've got an equation relating u and x already, right? So let's convert x equals 0 by plugging it in here and seeing what u equals. And let's do the same thing for x equals 2, okay? All right, so I'm going to take that top equation, and I'm first going to plug in 0 for x. So u equals 4 minus 0 squared. Well, that's 4, okay? And then I'm going to do the same thing for x equals 2. So again, coming up to that blue equation, u equals 4 minus, and I'm plugging in 2 for x. So this becomes 4 minus 4, which is 0. So my new a value is 4, and my new b value is what? Is 0, okay? So now we can rewrite everything in terms of u. So I've got integral. X equals 0 becomes u equals 4. X equals 2 became u equals 0, and now we're going to rewrite the integrand. So now I run into some yellow, which I'm replacing with what? With du, Remember, du has to go on the end. And it's a period at the end of your sentence, okay? Next thing I run into is a square root. And then I run into blue inside the square root, which I'm replacing with u. And now, again, I've got a much easier integral to work with. So now I want to anti-derive square root of u and plug in my new value. So here's where this is going to be a little bit different from indefinite integrals. You are not going to come back and plug this in as your last step. You don't need to because you changed these values. Now, what some books will tell you to do is just keep those values off, anti-derive, come back and plug in x's, and then go and plug in your final x's, which were the 2 and the 0. It works. I don't want you doing that because a lot of AP multiple choice questions will be set up only, and you get to stop right here and say, got it, I'm done. And of course, one of your options, or more than one of your options, will be to mix your x's and u's together. Okay, so I don't want you getting into that habit. However, I'm not going to let you stop. We're going to actually find what we were asked to find, which was the value of this definite integral. All right, so let's keep moving on here. Square root of x, or square root of u, I'm going to rewrite that as u to the 1/2, okay? Now I've got a whole new integral I get to work with. So let's anti-derive u to the 1/2, so that's new power is 3/2. Dividing by 3/2 is the same as multiplying by 2/3. And now I'm going to evaluate this at u equals 0 and 4. I did not switch my limits of integration and make it negative. If that bothers you, you can definitely flip and make negative. But as long as you plug in the top first, you'll be fine, okay? All right, so we have, I'm going to bring that 2/3 out in front because it's a nice factor coefficient. And then I'm going to plug into this piece here. So 0 to any power, that's going to be 0. And then plus or minus. Minus, and now I'm plugging in the purple piece. So I'll get 4 to the 3/2, okay? I'll put the 3/2 here as well so you see all the steps. Okay, so that 2/3, again, is coming with me. 0 to any power is 0. What is 4 to the 3/2? That's going to be 8. Remember, square root of 4 is 2, 2 to the 3rd is 8. So I am getting, as a final answer, negative 16 over 3. So again, I really want to highlight the difference here as opposed to indefinite u substitution, where we did go back in and plug this in. We don't do that with definite. And why is that? Because we change these values to be u values, so we don't have to go back and make our answer in terms of x, okay? We don't need that because we changed our a and our b because we had a and b to change, okay? If we were going back to the previous lesson, yes, you do have to plug that blue piece back in, okay? You just have to be so careful not to mix x's and u's or bad things will happen, right? Now, what does it mean that we got a negative answer? It means that we have more area below the x-axis than we do above. First, pause on your screen, go ahead and copy example 2 for me, and then also go ahead and identify u and du. All right, so I'm letting u be x cubed plus 1, meaning du will be 3x squared dx, but I just wanted the x squared dx part, so I multiply both sides by 1/3 there. All right, now I see a definite integral, so I need to make sure that I also change my limits of integration because right now 0 and 1 are x values. I need to make them u values. So let's come back to our u equation. So u is equal to, I'm going to plug in 0 for x first. So when x is 0, u is 1. And let's do the same thing for x equals 1. So u is 1 cubed plus 1, which is 2. So my a and b values are now 1 and 2 respectively. So let's rewrite. I've got integral. My a value is now 1, my b value is now 2. Then I'm running into yellow, which I'm replacing with 1/3 du. Again, 1/3 should come out here. Du on the end. The next thing I see is blue, which I'm replacing with u, and I still see that power of 4, which has not been highlighted out, so I need it here, okay? Look at this new integral. Look at how much easier that is to anti-derive and evaluate, right? Okay, so now I'm going to anti-derive, and that will be 1/5 u to the 5th, and I'm evaluating this at u equals 1 and u equals 2. See how I've never mixed x's and u's, okay? We need to make sure that we are sticking with the same variable. All right, let's go ahead and evaluate this. I'm going to bring that as a 1/15 in the front, and then just really focus on the u to the 5th, evaluating that at 2 and 1. All right, so we've got 1/15, and then I'm going to have 2 to the 5th minus 1 to the 5th. So I've got 1/15, and then 2 to the 5th, y'all can't see, I'm sorry. 2 to the 5th is 32, and 1 to any power is 1, so 32 minus 1 is 31, so final answer is 31/15. All right, so here's example 3. What would you say the inner part is? The inner part is going to be this stuff, right? That's what is to the power of really -2 because it's in the denominator. I'm going to force a pause on your screen. Go ahead and copy the example and then identify u and du for me. All right, so again, I'm letting u be x squared plus 3, so 1/2 du will be x dx, which is that yellow part. Now I do have a definite integral, so right now that -2 and that 0 are x values, we need to change them to u values. So let's come over here. So u equals, I'm going to plug in -2, my a value for x first. So I get 4 plus 3, which is 7. And then I'm also going to do the same thing for x equals 0. So u equals 0 squared plus 3, which is 3. Okay? All right, so now let's go ahead and rewrite. I've got integral. The purple part, the a value changes to 7. My upper limit now is 3. And what I was saying earlier is it's okay if your upper limit is not larger than your lower limit. If you want to flip it and make it negative, feel free to. If you don't want to think about that step, it will work as long as you plug in that top piece first, okay? All right, so I've got 3 here. Now let's rewrite our integrand. So the yellow part is 1/2 du. So I'm going to bring the 1/2 to the front. Du needs to be on the outside. And then I've got basically 1, because that's a placeholder, right? That u squared needs to be in the denominator, right? So the only thing I didn't highlight out really was that power of 2 in the denominator. So my rewrite looks like this. Again, or if you prefer, -1/2 integral from 3 to 7. And let's, at minimum, make sure we rewrite that as u to the -2 du. All right, so now we're going to antiderive u to the -2 and plug in our new values, that purple and green value. Okay. So antiderivative of u to the -2 is going to be -u to the -1, and I want to evaluate this at 7 and 3. Okay, let's go ahead and bring our coefficients to the front. So -1/2 times an understood -1 will be +1/2. And then u to the -1, let's focus on that, and evaluate that at 7 and 3. Okay, so we've got 1/2, and then I've got 7 to the -1 minus 3 to the -1. So I've got 1/2, so cleaning this up a bit, 7 to the -1 is 1/7, minus 3 to the -1 is 1/3, right? So let's get a common denominator here of 21. So multiplying top and bottom by 3 in this case, multiplying top and bottom by 7 in this case. So I still have that 1/2 in front. And 3 minus 7 is going to be -4. Got this over 21. So the 4 and the 2 do reduce, so I'm getting negative 2 over 21 as the simplified answer. All right, you all, that is what I have for you in terms of examples. The last thing I want you to do is write the steps for u substitution with definite integrals. I did make this little note of like, the difference is we are not going to take that step of plugging x back in. We don't need our final answer to be in terms of x because our answer isn't a function anymore. It's not a family of functions. It's a number. And as long as I switch my a and my b to be u values, I'm done with x's after that. Okay, I can just focus on everything being u's and going from there. So I'll leave you with this. Please end your notes with these steps, and I'll see you next time.